it's new technology. It's crazy technology. It's admittedly scary technology. If you want to learn more, I also have an article about this on
Yeah, you do.
Vitalik.ca.
It's actually really, really good.
No.
Most of your writing, it's technical, but it's accessible. I highly, highly recommend to check out Vitalik's articles and blogs, whatever you call them, on
Yeah,
your
but
website. It's brilliant summary of the work. Actually, Ethereum documentation period is really good. I think that's somewhat crowdsourced. That documentation is really, really accessible and brilliant. But let me ask about sort of other approaches to layer 2, like side chains. So the one popular one is Polygon. What are your thoughts about Polygon, which is a layer 2 network? Is it positive? Is it negative for Ethereum? Is it both? Does it have a future, which is its own chain, but it's using Ethereum? It's like based on Ethereum, essentially. Or maybe you can describe what it is.
Yeah. So I think there's a really big and important difference in security models between rollups and sidechains, which is basically that rollups inherit from the security of Ethereum, right?
Yes.
So like if I have coins inside of Loopring or Optimism or Arbitrum or ZK Sync, then even if everyone else in the world who is participating in these ecosystems like hates me and wants to steal my money, I can still personally make sure that no matter what happens, I get my money out. It might be a bit expensive for me to get my money out, and I have to do transactions like on the main chain, but I'll be able to do it. Whereas in Polygon, which is a sidechain, and so instead of being secured by Ethereum, it's also in part secured by its own proof of stake consensus with its own token. So if 70% of the whole, or even 51% of the holders of Polygon tokens wanted to take my money in Polygon, they can, right? So that's and like, to be fair, like there aren't even like the supply, I don't think, is even that widely distributed, right? So like potentially you could this idea of 51% of the token holders coming together and stealing everything, like it's not impossible, right?
Where does the scaling of Polygon come from? Like, why is it able to process much more transactions than the Ethereum main chain? What's the idea there?
I think in part, like I imagine, I'm not sure exactly what its capacity level is, but like I imagine it has a higher capacity because it's a bit more willing to take centralization trade-offs. And then another thing is that like if the Ethereum ecosystem, like even if it did not do that, right? If you think about an Ethereum ecosystem hypothetically scaling with sidechains, then you would have 100 copies of Polygon, and they would each have their own tokens, they would each have their own chains, and so even if each one of those chains was only as scalable as Ethereum, you could still, like, the total sum of them would still be 100 times more than Ethereum.
Okay.
The thing that I want to say in Polygon's favor, just to be very fair to them, like I really, I definitely really respect the work that they're doing. Yes. So start with a bit with that word of not criticism, caution, right? Like it's that they made this kind of deliberate trade-off for very pragmatic reasons, which is that the Ethereum ecosystem needs to scale now. And there are applications that want to do something now. And, if there aren't Ethereum-friendly options for them, then like they're not going to just wait peacefully and do nothing for 12 months. They're going to go to, either Binance Smart Chain or one of some other system, or potentially something that just has totally no alignment with Ethereum values whatsoever. But whereas with Polygon, like the best thing that you can say in Polygon's favor and against Optimism is that Optimism is not live and Polygon is live, right? Like it just takes more work to create a system that has these extra roll-ups security features. And so Polygon just said, we're going to be the system that makes the pragmatic trade-off. We're going to go, functionality first, and then, we can talk about adding back the security later. So I've talked to them, and like in principle, I think they're very, open to the idea of like adding more security and like becoming more, becoming a roll-up, or at least adding a Polygon chain that's a roll-up at some point in the future, which is definitely something I think they absolutely should follow through on. But like the fact that like they exist now, and so applications can kind of bootstrap now on a chain that even though its security isn't perfect, at least it exists and people can go use it. And then over time, the chain matures as the applications mature. Like, it's, I think, a very reasonable strategy, and I'm definitely really happy that they're part of the ecosystem.
Yeah, it's kind of interesting. The history of cryptocurrency has this tension of really good ideas that are hard to implement, so they take longer to implement, and ideas that are not as good but are faster to implement. This is like the story of like, you have like JavaScript that basically took over the world because it was quick to implement within 10 days, and then like later kept fixing itself. I don't know what to make of that. Sort of from an engineering perspective, I'm more and more becoming comfortable and accepting the fact that our whole world will run a technology that's not as good as it could have been, just because the crappy solution is faster to implement and it sticks. What do you make of that tension?
I think the compromise that we've been taking within Ethereum is, like, when we have to take the crappy solution, we look for crappy solutions that are forward compatible with becoming good over time. Right? Like, when you build the quick and dirty thing, like you would still already have ideas in your head about what the more complete thing with all the security features added on would look like, right?
Even if it requires a hard fork?
Yes. Like, even so, like, for example, with sharding, right? Like, I think it's likely that the first version of sharding that comes out, like, is not going to have, ZK snarks and data availability sampling, for example. But we know what these technologies are. We feel like we, have wrapped our heads around them. And so we know how to build a system where we can put all the pieces in place so that it becomes very easy to bolt those components on in the future. So, like, if you do things that way, right, then at the beginning you can have your system that has the functionality, but say has less security or like less sustainability or less of something else. But then over time, like, it's designed in such a way that it has this easy on ramp to adding those things, right? And if you don't think explicitly about like being future compatible, then you do often end up with a quick and dirty solution that backs you into a corner. And I mean, there are definitely cases where, like, I think the Ethereum ecosystem has suffered from that, and we have had to like expend pretty significant effort on, for example, removing features that we didn't realize that we actually can't sustain. Right. Like, one big example is just increasing the gas costs. So, like, making some operations more expensive when they because they should be expensive because they actually take a lot of time to process. So that's making like some things more expensive, kind of like taking some functionality away. So if you can like be cognizant of where you're likely going into the future, and if you don't know, like, even be cognizant of both the most likely paths that you'll take in the future, and thinking about your roadmap and coming up with a roadmap where that, like, if you wants to do either of those things, then you have a clean path toward it. That's probably the best kind of practical way to get the best of both worlds that we have.
Okay, let's talk about this wonderful process of merging. Okay, so there's the main net, which is the Ethereum 1.0 chain, or what should we say? The chain that uses proof of work as the consensus mechanism. And then there's, what is it called? The beacon chain that uses the proof of stake mechanism, and I believe the beacon has been deployed successfully, is working. So that was in December 2020. There's a bunch of questions around that that's fascinating as well, but I think the most fascinating question is about merging those two. When do the two chains, one that's proof of work, one that's proof of stake, merge? And what are the most difficult parts of this process?
Right. So, as you've said, right, the way that we have set up this proof of stake transition is that at first, the proof of stake chain just launches on its own, right? And this is the thing that happened in December. And the proof of stake chain has been running for close to 6 months now. I mean, by the time people watch this, it might actually be 6 months. But it isn't actually coming to consensus on anything except for itself, right? So the idea behind that is to just give the proof of stake chain time to mature, time for people to build the ecosystem around it, time to make sure that there aren't any bugs, and just like prove to the community that proof of stake actually is real and it's and a full transition is realistic because the thing that you're transitioning to already exists and already works. Mm-hmm. And then at some point in the future, you have this event called the merge, where you basically take the activity that's being done inside of the proof of work chain and you actually move it over into the proof of stake chain, so you get rid of the proof of work side completely. So the way that the merge will work is, it's definitely gone through a few different iterations. Like the earlier versions of this actually required more work for users and more work for clients. It was much more like, oh, there's this new chain, there's this old chain, and then everyone has to like migrate from the old chain to the new chain, and then at some point we'll forget about the old chain. The new version is designed to be much more seamless for users. Right. So basically what actually happens is that the old chain basically becomes embedded inside the new chain. Right. So starting from the merge transition block, every proof of stake chain block is going to contain a block of the what we consider to be the Ethereum chain today, but we'll call it the execution chain. And then at the same time, to create one of these blocks, you're not going to need proof of work anymore, right? So basically, at the same time, you would both get rid of the proof of work requirements for one of these blocks to be valid, but instead you require these blocks to be embedded inside of the proof of stake blocks, right? So you basically have like a chain inside a chain. And this is, from an architecture perspective, it's, you might think it's a little bit suboptimal, but it actually has some nice properties. It makes it easier to kind of think about the consensus and think about what we call the execution layer, like transactions and contracts kind of separately and upgrade them separately. And it also just means that the upgrade process is extremely seamless, right? Because from the point of view of a client that's following the chain, you basically have to update nothing, right? You're still following the same chain and follows the same rules, except instead of checking proof of work, you'll switch to checking that these blocks are embedded inside of blocks of the proof of stake chain.
Got it. So there'll be this merge block that will mark this transition.
Yeah.
And over time, I guess the new chain will contain the full record of all the transactions that's ever happened on the previous chain, on the old chain. So like maybe I'm asking a dumb question here, but in this process, is the new chain going to have all the information of the past transactions?
The new chain is not going to hold information from what happened in the Ethereum chain before the merge, right? So like Ethereum clients of the that people are going to use like around the time of the merge and soon after the merge, they're probably just going to sync and check the proof of work chain up to the merge, and then they're going to check the proof of stake chain. Yeah. But at some point in the future, I think people will just stop bothering checking the proof of work before the merge.
Got it. So that old history information is not important for the future. Or like if you're operating actively on the new chain, that history is not important to you.
It's not important. Let's see. So it's not strictly important for just like in any like smart contract or just like applications that run on the blockchain. It can be important to users and it can be important for some applications, but we're basically saying that like maintaining and serving that is not going to be simultaneously the responsibility of every Ethereum node. If you want that information, there can be separate protocols for backing it up. And like these other protocols actually exist, right? Like there's something called the Graph, which is doing some history retrieval. Potentially, you can just take that entire chain and stick it on BitTorrent. Like there's lots of ways to like archive it and create kind of customized search protocols for it.
So what's your sense why... so there's a Python 2 and Python 3, and it took forever for people to switch. What's your sense why this merge has been taking longer than perhaps was expected?
I think the biggest reason is just we've been underestimating the technical complexity. There's a lot of technical complexity in making a successful proof of stake chain. There's a lot of technical complexity in actually figuring out the transition process.
So that's bigger than social complexity. So it's the technical complexity, you would say, is the bigger reason for any delays than the social complexity.
I actually think so. I think we've been very fortunate to not have too much social complexity around the merge.
So not much drama.
No. I think the biggest part of the reason is just because we have been talking about proof of stake and sharding as being part of the roadmap since almost the very beginning of the project, right?
Yes.
Like the very first proof of stake blog post is from January 2014, which was 2 months after the project started, and like maybe even a day after the announcement. So it was proof of stake was not something that we kind of put on anybody by surprise. And then when the DAO fork happened, and the people on the ETC side split off, I think it also just happens that a lot of the people that were not willing to stomach the DAO fork and then join the ETC side, they were the more Bitcoiny types, and the more Bitcoiny types do also tends to like proof of work more. And so like that also sort of ended up, sort of like purifying the communities on both sides, I guess. So Ethereum Classic is not switching to proof of stake, and they're happy with their setup. And by the time that it came to the Beacon chain launching, and now I think the community is very strongly in favor of the proof of stake switch.
But let me ask the question that no engineer wants to hear, which is the question of timeline. When do you think the merge will happen? Do you have a sense it might happen this year? Do you have a sense it might be pushed towards next year, 2022, or even beyond?
I think early 2022 is like the most realistic. There's definitely still like an optimistic case of it happening this year, but like the realistic thing to count on is definitely the early part of very early part of next year.
Is there specific things that stand out to you that are like they'll make you feel good about progress if you see it happening?
So the thing that we had last month is we had this online hackathon called Rayonism, where basically a bunch of the different client developers that are going to be part of the transition like hacked together some test nets of the post-merge Ethereum chain. So these were only test nets of what would happen after the merge. They were not test nets of the transition itself. So the thing that people are working on now actually is the transition. So having a full specification of both the transition and post-transition. I mean, we have specifications now, but like, realistically, they'll probably needs to have a couple of changes and have things that continue to be ironed out, and then have a test net that does both the transition and the post-transition. And then like once you have a test network, then you just have to do a lot of testing and audit it, and then do some runs on not just a specialized test network, but on, say, an existing test network like Ropsten or Rinkeby that Ethereum people already significantly use. And if it works, then you can deploy the transition on mainnet.
Just as a quick comment, because this is fascinating, in August of last year, there was this Madala.
I believe it's pronounced Medasha. It's a South American subway station. I forget where.
But spelled with two L's.
Yeah, because that's that's how Spanish works, right? Like the two L's have
Madasha.
Yeah.
Okay, cool. Anyway, but I read about it in middle of August 14th. There was an incident on that test net. How does this process work? Like, what do you learn from those kinds of incidents when stuff goes wrong in the test process?
I think that incident was that there was a consensus failure of some kind, as I remember. Like basically just different clients interpreting things in different ways, and then one of them getting kicked off the network. And then it had ended up taking a while to actually like get everyone to get back online. Like a big part of the reason why it took weeks to resolve, right, is because it's on a test network, like the coins are valueless. And so there's not really this big push of any kind for people to actually, go and download a new client so they can start participating again. And so, it definitely took a while until the chain started finalizing again. And then also like there was, I think, another round of just not finalizing in October, as I remember. There were definitely things that we learned. Like there were a lot of things, especially that client developers just learned about, like optimization and how to build their clients in a way that they can process things efficiently. There's a lot that we learned from just like seeing the full life cycle of what happens when more than a third of the validators go offline and then finalization stops, and then that kind of weird, unusual state of the chain continues for a while, and then eventually everyone who is not participating just gets enough of their stake. We don't use the word slashed, we use the word leaked for this, but like basically also burned until the people who are participating go back up to 2/3, and then the chain goes back to finalizing. So just seeing all of those edge cases play out live, I think actually helped a lot, and probably helped to really contribute to making us feel better about mainnet.
I mean, there's also an incident just recently in April 24th of 2021 where this was on Beacon, I guess. There was a bug discovered in the software client Prism that prevented roughly 70% of validators on the network from producing blocks. I mean, maybe you can comment on what happened, but broadly, like the big picture, what kind of stuff are you worried about in terms of problems that might arise? Are we talking about small bugs? Are we talking about like emergent unexpected social bugs? What are the things that worry you about the future of Ethereum that you want to make sure you construct mechanisms that prevent those things from happening?
So one of the lucky things there was that this particular bug only prevented proposals of blocks. It did not prevent attestations, right? So attestations is just a mechanism for voting on blocks. And it's the attestations that are actually responsible for the chain finalizing. So like coming to this more permanent agreement on blocks, right? So the chain was actually quite stable all the way through. I think the thing that we generally learn from these experiences is just how valuable it is to have this multi-client network, right? So this is one of these areas where I think Ethereum distinguishes itself from like Bitcoin, for example, right? That in Ethereum we don't have one single client that everyone just runs, right? There's multiple implementations of the protocol, and these multiple implementations, they all process and verify the blocks that each other can verify, right? So they all speak the same language. Now sometimes when there's a bug, they disagree, right? And when two clients disagree because of a bug, we call this a consensus failure. And consensus failures are pretty serious, right? And when you have client monoculture like Bitcoin does, then like it's more rare to have consensus failures, though you still have them, actually. Bitcoin had a consensus failure between two different versions of the same client back in 2013, but they're less likely to happen. But the interesting thing is that the multi-client architecture has actually, I think, saved Ethereum much more than it's hurt it. So even in this most recent incident, right, like Prism was not producing blocks, but all the other clients were still producing blocks.
There's four others, right?
Yes, it's Prism, Nimbus, Teku, and the Lighthouse. And then also Ethereum back in 2016 had this fun event that we call the Shanghai DOS attacks. They're called that because the attacks started right on the first day of our annual conference, DEF CON, that happens to be in Shanghai that year. So what happened basically was that someone came up with a way to create blocks that were very slow for one client to process, but not the other client. So at that time, there were basically two Ethereum clients. They were called Geth and Parity. Right now, I think the top three ones are Geth, Nethermind, and Besu. But what happened as a result of us having two clients is that the attacker was just not able to come up with blocks that both clients were completely failing at processing. And so a lot of the miners and a lot of the network participants, they just kept on switching between the two implementations depending on which one worked. And that actually really helped the chain kind of survive through that month of attacks, as the attacker just kept on hammering at our system and identifying all of the weaknesses and just forcing our clients to do this rapid sprint of just optimizing the hell out of everything and make sure there aren't any of those DOS blocks or DOS bugs remaining. So that was another example. And then as a counter example, so something that also shows the point from the other side. Bitcoin had this bug in 2010, right? The balance overflow bug. Basically, someone created a transaction that had two outputs, and those outputs were both of a few billion Bitcoin, so like about 2 to the power of 63 satoshis. And then if you add those numbers together, you go above 2 to the power of 64. And of course, computers, like once you go above 2 to the power of 64, you wrap around. And so the Bitcoin nodes thought that there was enough money to pay for the transaction because it was asking for, let's say, like a billion satoshis or something, but actually it was asking for 2 to the power of 64 plus a billion. And so, the attacker just managed to create like billions of Bitcoin out of thin air. And this was not only discovered and fixed after something like 12 hours. But if Bitcoin had been a multiple implementation system, then what would have almost certainly happened is like one of the clients would have bugged out, but the other clients would have probably actually had a check for that, right? And so there would have been a consensus failure, but at least that would have alerted everyone that there is a problem very quickly, and it also would have given everyone just like obvious social permission to go and pick whichever one of the chains is correct and solve the problem. So that's, I think, a big learning that we've had from multiple of our experiences in the Ethereum ecosystem, just like validating this multi-client model. And to be fair, it's a model that we get criticized for a lot, right? Like Bitcoin people talk about, the risk of consensus failures that this creates. VC types are like, well, isn't it expensive and wasteful to fund 3 software teams when you could just be making, one quote focused effort? They love the word focused, and Ethereum is not that, but it's amazing despite not being that.
Yeah.
Basically, yeah. So that was interesting, and then there have definitely been other learnings as well, just from like seeing the chain live and seeing what actually is the staking experience like, what are the actual incentives for all the different participants. So I definitely feel like we're gaining a lot from this sort of 1 year of trial running the chain before we actually make all of Ethereum depend on it.
Let me ask perhaps a strange question, but proponents of Bitcoin will say things like Bitcoin fixes everything. So why do we need Ethereum versus like Bitcoin plus Lightning Network for scalability, and then using Bitcoin with this proof of work for security? So in this kind of, it is perhaps sort of a strange question, but it's a high level question. Why do we need another technology? Yes, it has a bunch of nice features, but like, doesn't Bitcoin fix everything already?
So the thing that always attracted me about Bitcoin is, these values of, decentralization, creating these open permissionless systems that anyone can participate in and that aren't just going to flop over and die if whoever created them gets bored, and that are resistant to whoever runs them breaking the rules and all of these things, right? And I think that pretty strongly that these principles are really valid and important to much more things than just money, right? Like Bitcoin is the blockchain for money, and Ethereum is built from the start as a general purpose blockchain, right? It's, there is Ether, the asset on Ethereum, but then you can also make decentralized financial things, what we call DeFi today. You can make like ENS, the decentralized domain name system. You can make prediction markets on it. You can make totally non-financial systems that just keep track of whether or not some certificate was signed or whether or not some cryptographic key got revoked. There's this big long list of just interesting things that you could use about blockchains to do, right? Basically, they are sort of the missing piece that where without them, the kinds of things that a decentralized computer network can do is very limited. And once you have them, a lot of those limitations end up going away. And so Ethereum was always from the beginning about that, right? It's about hey, this isn't just money. There's so much more that you could do if you could just go ahead and make any infrastructure or digital institution or DAO or whatever you want to call it, where the kind of the base layer of the logic is just executed in this open and transparent way where everyone can see what's going on. Or, if you like your zero knowledge proofs, at least everyone can see proofs that prove to you that what's going on follows the rules. And, you don't need to just constantly keep trusting centralized actors. And
Hence the smart contracts
exactly
as being a sort of a core technology as part of Ethereum.
Yes, exactly. Smart contracts, the computer programs that are running on Ethereum, they are like the core of what makes Ethereum general purpose.
Yeah.
So I do think that, there's a lot more that wrong with the world than just money, right? Like, I'm not one of these people who thinks that, if you get rid of fiat currency and you replace it with cryptocurrency, then suddenly wars are going to go away, right? Because, like, first of all, like seigniorage revenue is only a small portion of government revenue, right? It's like what, 5-10%, something like that. Second of all, like, if you are the sort of this is one of the things I don't even get about their philosophy. Like, let's say you're the sort of person who is an extreme and very distrusting libertarian, and you think that these governments are terrible, right? Like, we know today that governments fund a combination of things like welfare and things like the military that goes and like bombs people in Afghanistan, right? And the question you have to ask is like, okay, you with your new, magic newfangled cyber currency that takes over the world, take away the government's ability to have seigniorage revenue, and so you reduce the government's revenue by 10%. If the government is that evil, which portion of its expenses is it going to take that 10% from? Is it going to stop the bombing people in Afghanistan, or is it going to cut welfare? If you think it's the first, you have a very optimistic view of the government, right?
Yeah.
So that's, I guess, my perspective on like why the whole we're going to save the world and create peace by like denying governments the right to stealth taxation kind of perspective doesn't really make much sense for me. And I do think that there is real value that comes from a decentralized and open currency, like just the fact that there is a financial infrastructure that anyone in the world can go ahead and use, right? Like it's that's something that can easily be a big boon for people, right? There's a lot of places where the currency is much less stable than the dollar, and these people, like, they don't like, well, if they use Bitcoin, their only option is to get Bitcoins, right? Which, are also pretty volatile. If they use Ethereum, then, they can get Ether, but then they can also get stable coins, right? And you might think that, oh, you're not being ideologically pure. Now you're giving them stable coins, which are mirroring dollars, and obviously dollars are going to collapse too. But the reality is that dollars are vastly more stable than the Venezuelan bolivar. So, like, there are really meaningful and beneficial things that you can give to people by having a global and open financial system. But I think if you want to actually do that, like, you have to have much more than just a currency, right? And then if you want to go beyond financial things, then, you have to obviously have much more than a currency. And then, you also have to actually take scalability seriously, because non-financial applications, like, nobody's going to pay $5 a transaction for them.
Can we return to dogs?
Sure.
No.
The other one's categorically forbidden?
Yeah, categorically forbidden. Is there any cryptocurrency based on cats, actually?
I think there are. Like, there was Catcoin, there was Nancoin. For some reason, they just didn't catch on as much as the dog coins did.
Okay, so let's talk about Dogecoin and Elon Musk. Elon said that, quote, ideally, Doge speeds up block time 10x, increases block size 10x, and drops fee 100x. Then it wins hands down, end quote. You said in a blog post, partially responding to that there are subtle technical reasons why this is not possible. To this, Elon said that you, quote, fear the Doge. So let's talk about this. What are the technical hurdles for Dogecoin that prevent it from becoming one of the primary cryptocurrencies of the world? And do you, in fact, fear the Doge?
I definitely feel obligated to correct the record. I definitely do not fear the Doge.
Okay.
I love the Doge. I actually visited the Doge in Japan a few years back. It's she's an amazing dog. She's still alive.
Wait, the original Doge?
Yeah.
Oh, wow.
So, we accept Doge every year for our annual DEF CON conferences. So I definitely, don't think Ethereum is opposed to Dogecoins. I kind of want to feel like, Ethereum is at least a little bit in spirit itself a Dogecoin. And then, as I mentioned, I love Doge. I bought a bunch of Doge. I still hold a bunch of Doge. On the scalability question, like the challenge basically is like the limits to scalability and the trade-offs with centralization, right? Like if you just increase the parameters without doing anything else, then it just becomes more and more difficult for people to validate the chain, and it just becomes more likely that the chain becomes centralized and becomes vulnerable to all kinds of capture.
Mm-hmm. So does it need like some of the layer 2 technologies that we've been talking about?
I personally think that, if Doge wants to somehow bridge to Ethereum and then people can trade Doge thousands of times a second inside of Loopring, then, that would be amazing. If they want to just like take ZK rollup style technology and just have thousands of transactions a second on their own chain, then that's, that would be a great outcome as well.
So is there ways for Ethereum and Dogecoin to work together? So, okay, so there's a power behind a person like Elon Musk pushing the development of a cryptocurrency.
Mm-hmm.
Is there ways to leverage that power and that momentum to improve Ethereum, to improve some of the sort of cryptocurrencies that are already technologically advanced and pushing forward that kind of technology?
I definitely think there's room for...
that there's that meme of Doge like taking over, like that storm.
Yes, I've seen it.
Is there a way to ride that that storm, that wave of the Doge that's taking over?
I think if we can have a secure Doge to Ethereum bridge, then that would be amazing. And then when Ethereum gets its scalability, any scalability thing that works for Ethereum assets, you would be able to also like trade wrapped Doge with extremely low transaction fees and very high speed as well.
Is there precedence for building secure bridges between cryptocurrencies? How difficult is this kind of task?
It's definitely something that's in its infancy. There definitely have been some cross-chain interaction things that have been done before. The earliest is probably the concept of merge mining, right? When a chain just makes its entire proof of work algorithm dependent on the proof of work algorithm of another chain. Right, so I think famous Dogecoin actually merge mines to Litecoin, which is, I think in retrospect, not looking like a very good choice because now Dogecoin is bigger than Litecoin. If there's potentially some way for Dogecoin to merge mine with an Ethereum proof of stake of some kinds, then like that could be an interesting alternative. So that's one type of like chain interaction. As far as like bridges, like one chain reading another chain, early in Ethereum's history, there was this project called BTC Relay. It's a smart contract on Ethereum that just verifies Bitcoin blocks. I think people stopped really caring about and maintaining it because there just weren't enough applications that were actually interested in using it at the time, and then the transaction fees got too high to actually maintain it. So I think if we want to make a BTC Relay 2.0 and that becomes cheaper because it uses snarks or something like that, then you probably could. And maybe now's the time when you actually can do that sort of one-way verification. But the one challenge, though, is that if you want to have a bridge that allows you to move assets between chains, then you don't just need one-way verification, you need two-way verification, right? And Ethereum can verify anything because Ethereum smart contracts can just run arbitrary code. But if you want Bitcoin to be able to do things based on what happens in Ethereum lands, then Bitcoin would have to basically, they can do everything with soft forks because that's their religion, but they'll do it that way. And if Doge wants to make a fork where that allows for two-way transferability with Ethereum, then they could. I think that would be a lovely collaboration to make if there's interest. I think there might actually even be some multi-sig funds that has some funding. It's just a bounty for someone to make a bridge between the two.
Oh. Could you maybe try to psychoanalyze Elon Musk for a brief second? So what are your thoughts about Tesla and Elon Musk's journey through the cryptocurrency world? So first with Bitcoin and then with Dogecoin. So holding a large amount of Bitcoin. And I believe at least considering the acquiring and holding a large amount of Dogecoin. Positives, negatives. What do you think the future for Tesla and SpaceX in the cryptocurrency space looks like? Do you think they'll consider Ethereum?
Hmm. I'm sure that if they stay in the cryptocurrency ecosystem at all, then they have to at some point. Right?
Yeah.
Bitcoin number one, Dogecoin number. I mean, come on, it deserves to be number three, and then or number two, and then Ethereum can be whatever that other number is. The
Well, if Ethereum only becomes a dog coin somehow, maybe change the logo to incorporate a dog of some sort, almost like Doge, like sneaking behind.
Oh, that would be fascinating.
When the merge happens.
And I think like Elon, you definitely, I think you would make a mistake if you were to kind of ascribe too much like sophisticated malevolent or any intent, like deep intentionality to the whole process. I think like he's just a human being and he likes dogs just like I like dogs.
Yeah,
right?
that is. I think that is literally the reasoning behind the whole Dogecoin thing. There's some aspect to which, I mean, the guy helped launch a car into space, right? Like you could ask, like, what is the purpose of that? I think the purpose of that is fun. I think he truly is more and more, especially lately, embodying the whole idea that the most entertaining outcome is the most likely, and he's fully embracing the most entertaining outcome. And in many ways, Dogecoin is the most entertaining cryptocurrency. As cryptocurrency becomes more and more impactful in the world, people are getting more and more serious about it. And so he's selecting the cryptocurrency that is the least serious and the most fun. And there's something to that, like coupling fun with technological sophistication, and somehow figuring out a way to do that.
Absolutely.
To do that well.
And I want the world to be fun. I think the world being fun is great.
Okay, let me ask about a couple out of the technologies, if it's okay.
Sure.
What are your thoughts about Chainlink and hybrid smart contracts that utilize off-chain external data sources?
And I think it's definitely necessary for smart contracts that do a lot of things to use off-chain data of some kind, right? Like if you want to have a stable coin, you need a price oracle so you know what price you're targeting. If you want to have some fancy, crop insurance gadget, like I think EtherRisk has been doing a lot of good work with that. In I think it was either Kenya or Sri Lanka or both. Like they're making a lot of good progress in some of those places. Like you need some kind of oracle to tell you, did it actually rain in this particular area? If you want to have like assets that mirror other financial assets, you need an oracle. If you want to have a prediction market, you need an oracle. And so projects that provide oracles are definitely really important. I mean, there are definitely different kinds of use cases. Like Augur is more about events, and the Augur Oracle is designed, like I think, differently from Chainlink, right? Like Chainlink emphasizes the whole, like we have a fast automated thing that just like gives you data quickly. Whereas Augur is more, we don't give a crap about speed. And look, we don't need to give a crap about speed because if you want to